हो गया? Okay. Hello everyone. I think we are live now. स्क्रीन को हाँ थोड़ा और नहीं रहने दो, ठीक है, कोई नहीं. Hello, hi everyone. My name is Karan Masru and welcome to this ultimate revision session on database management system and warehousing. Can someone please confirm if I'm properly audible? Good morning. Am I properly audible? Okay, great. Okay, so let's wait for 10 more seconds for more people to join and then we can begin. Okay, 10-15 more seconds. Okay, thank you for confirming. So our agenda for today is basically we are going to revise the DBMS part through previous year questions. That is what I've planned. So initially we'll have a brief overview on the syllabus of database management and warehousing, and then we'll start with some previous year questions. Okay, so first of all, let us look at the syllabus. So this is your syllabus for database management and warehousing, where you first of all have the ER model, basic entity relationship model. Then we have relational model, where so basically where we convert the data or represent the data in terms of different tables or relations. And then based on that, you can have concepts of keys, joining different types of joining the tables using keys like foreign key, then defining primary keys, giving the constraints, etc. Then there is relational algebra. Now this is the query part. Relational algebra, it is a mathematical term, mathematical portion using which you can query different data as and when required. Then you have tuple relational calculus, again one more mathematical thing, but relational algebra is the procedural, whereas tuple relational calculus is declarative. Then we have SQL, structured query language, used in most of the softwares, right, where you can run the SQL queries to get the data. So this relational algebra and tuple relational calculus are the theoretical portion. You can say SQL is the practical implementation of that. Then there are integrity constraints like domain constraints, key constraints, referential integrity constraints, right? Then there are normal forms. So for normal forms, you will also need functional dependencies. Okay, we will also cover that today through previous year questions. And so there are functional dependencies, then 1NF, 2NF, 3NF, and BCNF, right? Then there is file organization, how you organize the file. Then there is indexing. So basically indexing means you have primary index, secondary index, clustering index for better and fast retrieval of data. We'll also look at some questions based on that from previous year. Then you have data types, what different types of data can be there. Then data transformation such as normalization. Now normalization means you try to bring the value of different attributes of data at a particular level or a scale. Okay, so if one range is 0 to 1 and another is 100 to 200, you try to normalize them. Okay, then discretization is basically you discrete the data. Okay, so that your analysis is better. Again, sampling, you sample it into different things. Then compression is basically in order to reduce the size, you compress the data. Then data warehouse modeling, so how do you store a large amount of data from different databases? What are different models for that? If your data is multidimensional, how can you do that? Concept hierarchies means, for example, you can form different hierarchies of the data in the warehouse for better retrieval and better analysis, better data mining. like you can have, let's say, overall you can have country, then in country which state, then in which state which city, and so on, right? So you basically have hierarchies, right? And then categorization and computation, so you put data into different categories again to observe the different trends and to make work more efficient. Okay, so this is your syllabus for this. Now I think let's move on to some previous year questions. Okay, so this is the first question from GATE 2019, where it says that consider these three relations P, Q, and R, where for relation P you have X, Y, and Z attributes, for Q you have X, Y, and T, and for R you have Y and V. Then how many tuples will be returned by the following relational algebra query? Okay, try everyone this, then I will solve. Also, please don't search on the internet, try it by yourself, because it will have two advantages. First is, if you are able to solve it by yourself, it will boost your confidence. Second is, if you are not able to solve it on your own, then you will find where you are getting the mistake. In case you got the wrong answer or for any reason you were not able to solve, then when you will look at the solution given by me, you will know where you are making the mistake, so you will not repeat that mistake. Okay, so try this question. I'll give some seconds, then I'll continue, because we have to discuss a lot of questions. So what will be the answer for this? Can someone please tell me? How many tuples will be returned by this relational algebra query? Okay, so how can you solve it? First of all, you get the result for this query, you get the result for this query, and then you perform the set difference. Okay, now here please don't think that I am discussing only previous year questions, because if you have any doubt, I'll go in a bit of depth of theory also, so that alongside numericals and previous year questions, the theory will also get revised. Okay, so here if I talk about the first query, then here what is there? So here what does first query say? First of all, you do cross product of P and R, you do cross product of P and R, then you apply the condition, you take only the tuples where R dot V is V2, and this is the end sign, and P dot Y equals to R dot Y. So first of all, you do P cross R. Now please understand here, don't try to generate all the tuples. It will waste a lot of time, and you might also get confused in between and get wrong answer. Okay. So you take the tuples from P cross R, where R dot V is V2. So R dot V means the value of this attribute is V2. So basically you do not take these tuples in cross product only, because you are only considering the tuples where R dot V is V2. Now you take the cross product of this with all the four tuples. And what is the second condition? This is AND, means both the condition must satisfy. P dot Y equals to R dot Y, means P dot Y must match with R dot Y. Here R dot Y is Y3. So here P dot Y must match with R dot Y, and R dot V is V2. Okay, just a second guys. Okay, so there is one more tuple which we have. Okay, so we have two V2s. So now either Y3 or Y2 will join here. Now you see here it is Y1, so it will not join with any tuple. This will not join with any tuple. Here it is Y2, and here also it is Y2. So this tuple will join with this tuple, and this is Y4. It will also not join, because Y value must be same and R dot V must be V2. So here what is the answer that you get? You get X2 Y2 Z2 Y2 V2. Okay, X2 Y2 Z2 Y2 V2. Okay, now this Y2 is R dot Y2, and this is P dot Y2. Okay, so this is P dot Y and this is R dot Y. Don't get confused. And from that I select only the X value. So if I select only the X value, I will get as X2. Okay, so from this I got X2. Now let's try to solve this. Here we take cross product between Q and R, we take cross product between Q and R, and here what tuples we will take? We will take the tuples where Q dot T value is greater than 2. Q dot T value is greater than 2 means this and this are not taken, and Q dot Y equals to R dot Y. So I am taking the cross product, and this Y value and this Y value must match. So Y2 must match with Y2. So this will go combine with this as well as this, and Y1 will match with Y1. So this will combine with this. So what are the tuples that I will get? X1, Y1, 6, Y1, V1, then X1, Y2, 5, Y2, V3, and X1, Y2, 5, Y2, V2. And from this, what I will do, I will take only projection on X. So I will take only X, okay, in all these tuples. So I will get what? Only there is one value, X1. Now this returns me X2, this returns me X1. What is set difference? The set of all values which are present in this but not present in this. Now X2 is not present there. So this X2, this is one set, minus X1 will give me what? X2 only, because X2 is not present here. What is the meaning of set difference? ABC minus BCD. This will give me all the values which are present here and not present here. This will give me A. So here I will get X2. So the number of tuples returned will be 1. Is this clear? Please be active in the chat section, and please let me know if there is any doubt in this question. Okay, great. Let's move to next question then. Okay. What does this question say? Consider a database that has the relation schema CR where you have student name and course name. An instance of the schema is given here. So this is one instance, this is the student name, and this is the course name taken by the student. The following query is made on the database. You select the student with name SA, and take the course name from that and put it into T1, and then you take T2 as CR division operator T1. Then the number of rows in T2 will be. What will be the answer for this? So how can you solve such question? This was asked in GATE 2017. So first of all, you try to get T1. What is T1? Sigma student name equals to SA from this table. So you select the tuples where you have the name SA. So you select this, this, this. Okay. Now you select the course name from this. Okay. So course name is CA, CB, and CC. Okay. So in T1, you basically have course name, and the values are CA, CB, and CC. Okay. And in T2, you take CR divided by T1. So it is CR division operator T1. Okay. Now what is the meaning of division operator? Means from CR, see, first of all, what is the schema of CR? It is a student name, I am writing in short, and course name. Okay. Division T1, what is the schema for this? It is course name. So when you apply the division operator, what you will get is, you will get the name of students who are enrolled in every course. Are you getting my point? When you say A divided by B, and if the relation schema of A is, let's say, P1, P2, and P3, and if the relation schema of B is P2, P3, then A divided by B will give you all the values of P1 which are associated with every value present in P2 and P3. Are you getting my point? So here you will get the name of students who are associated with all the courses. Means all these courses, CA, CB, and CC. They might be associated with even more course, but they must be associated with at least these. Okay. So what will be the values here? You see, uh, uh, so student A is associated with all these three courses. So student A will be taken. Now student B is associated with CB and CC, but not all three. Then student C is associated with CA, CB and CC, so student C will also be there. Then student D is associated with CA, CB, CC and CD, but he is associated with at least CA, CB, CC, so student D will also be there. Student E is associated with CA, CB but not CC, so he will not be taken. And student F is associated with CA, CB and CC, so student F will also be taken. So 4 student values will be returned, and hence the number of tuples will be, number of rows will be 4. Yes, great, Pawan. Is this clear? Is everything clear? Shall we move on to next question? Why, what is the question? Why change why changes are reflected on the base table? I didn't got the question properly. Can you please clarify, Rohil? Why changes in view table is reflected on base table? No, we have not we are trying to solve it using this. It will be different only. It will be assigned in T2. I was just solving here. Is that clear? Okay, great. Okay, come on, hurry up, tell me the answer for this. Okay, GATE 2021. The following relation records the age of 500 employees of a company where employee number indicating the employee number is the key. So this is the key, employee number and age are there, employee number is the key. Consider the following relational algebra expression. What does the above expression generate? So what does this expression generate? So let's see what they are doing is, for this is the projection on employee number. I'm not sure whether this is clearly visible or not, so let me write it down. So they are taking the projection on employee number, and inside that they have employee age. Okay, and this is the join condition where age is greater than age 1, and they have P employee number 1 and age 1 from employee age. So what they are doing is they are taking a natural join between employee they are taking a join between employee and employee age only, so between the same table. So they have renamed it as employee age 1 and this is employee age, and here they have renamed the attributes as P employee number 1. This is not P, I guess. Okay, this is row. Okay, this is row rename operator. They have renamed the attributes as employee num 1 and age 1. Okay, and what they have said, you will only take the tuples where age is greater than age 1. Okay, now you see here which all employees will come. For example, if I have employees 1, 2 and 3 and their age is 12, 13 and 15. Okay, so this is your employee age table and this is your employee age 1 table, because we have just renamed, so it is 1, 2 and 3 and 12, 13 and 15. Okay, now you take join between them based on this condition. Basically you take a cross product, so each and every tuple here will be associated with each and every tuple here, and then you just take the tuples where this condition is true. So age must be greater than age 1. Now you see here, when this tuple will be associated with this, 12 is not greater than 12, so this will not be taken. Now this tuple will be associated with this, 12 is greater than 13, no. Now this tuple will be associated with this, 12 is greater than 15, no. Now this tuple will be associated with the first tuple, 13 is greater than 12, yes. So 2, 13, 1, 12 will be there. Okay, then what else? Then you see 2, 13, 3, 15. This tuple will not be there because 13 is less than 15. Now 15 will be associated with this. So 3, 15, 1, 12 will be there because 15 is greater than 12. And 3, 15, 2, 13. This will also be there because 15 and 13 is there. Okay. Afterwards, they have taken the projection on employee number. Remember, this is employee number. This is employee number 1. Okay. They have renamed it. So they will take a projection on this, and in relational algebra we do not take duplicate, so I will get 2 and 3. So what are 2 and 3? These are the employees whose age is not minimum. Obviously the employees whose age is not minimum will be taken. Why? Because here I am doing the join with the same table and I am specifying the condition that I need an employee whose age is greater than this employee. Now if a employee has age greater than even one employee, then also his or her age will be taken here. Are you getting my point? Only the employee whose age is minimum for him or her, this will be false for all the matching tuples, okay, or in all the tuples in cross product. So this will return me the employee number of all the employees whose age is not minimum. And which option is correct? C. Is it clear? Okay. Is this clear, guys? Please be active so that we can cover more things in less time. Okay, great. Let's look at the next question. This is also an interesting question asked in GATE 2022. Consider the following three relation in a relational database: employee, employee ID and name; brand, brand ID and brand name; and own, employee ID and brand name. Which of the following relational algebra expression returns the set of employee IDs who own all the brands? See, this is the detail of employee where you have employee ID and name. You have brand details here where you have brand ID and brand name. You have one table own where you have employee ID and brand ID, means this employee owns this brand. Okay. And for one brand there can be multiple owners, and for one owner there might be multiple brands which he or she might be owing. Okay. There is no nothing restriction given on that. Which of the following relation algebra expression return the set of employee IDs who own all the brands? Now, please be careful. As soon as you hear the word all, it means chances are there that you need to use division operator. Are you getting my point? In the last to last question, what was the question when you said T2 is, when we said T2 is CR divided by T1, it means we want the name of all the students who are enrolled in all the courses by T1. Are you getting my point? So whenever you have all the, if the question is all the things, so chances are you will use division operator, and we can see here division operator is there in one of the options, right? So how can I get that? So what I want is, I want the employee ID of the people who own all the brands. Okay. So what I need to do is, can I say own employee ID comma brand ID division. Here I want all the brand IDs. So when I say own employee ID brand ID division brand ID, means the employees who are associated with each and every brand ID will be considered. How can I get a brand ID? Where is the brand ID? It is here. So I can say projection brand ID from this table, right? So this will give me the answer. You can see here pi employee ID brand ID own division pi brand ID brand. So here, as soon as there is a division operator, what this will return? It will return the employee ID of all the employees who are associated with all the brand IDs in this own table. Remember, they are associated with all the values in this table, but where is the association? It is here. Okay, so it is present here. And after that they have again taken the projection of employee ID, but even if you do not take, it will be okay. So your option A is correct. But this was a multiple answer, like a multiple select answer type, so another can also be true. Now please remember, this is not true, because when you say pi brand id own, it might not have all the brand id information, because there might be a brand who is not owned by any of the employees in the given data set. Okay, so that brand would not be here present. So when you say you want the employee id of employees who own all the brands, here you need to take all the brand ids, and you will get all the brand ids from brand table, not own table. Okay, so this condition gets false. Now there are two conditions remaining. Okay, now you see here, so here what we need to do is, we need to see division operator is a derived operator. Okay, it is not uh, like basic operator. Okay, so I want to represent it in terms of basic operators like set difference, multiplication, set difference, etc. Okay, yeah. So now how can I represent it? So one way is I can just tell you the formula. Another way is we can try to derive it so that we remember it for longer time. So what I will do is, let's say there is my table A where I have A1, B1, C1, where I have let's say I have a table R where I have attributes A, B, C and D, and I have a table S where I have attributes C and D. Okay, here it is C1, D1, C2, D2. Okay, and here I have A1, B1, C1, D1, A1, B1, C2, D2, A2, B2, C1, D1, A3, B3, C1, D1, A3, B3, C2, D2. Okay, now if I do R divided by S, then see what I will get in this result. I will get only A and B attributes, and I will get those attributes which are related with every tuple of S. Okay, so I A1, B1, and where will I see whether they are associated or not? In the R table. So A1, B1 is associated with C1, D1 as well as C2, D2. So this will contain A1, B1. A2, B2 is associated with only C1, D1. So that I will not get. A3, B3 is associated with both. So I will get A3, B3. Okay. So how can I get this? So what I can do is, let us assume that all values of AB present here are associated with each and every value of S. All values of AB present here are associated with each and every value present in S. So how can I get that? I can say pi A comma B of R cross product S. So it will give me A1, B1, C1, D1, A1, B1, C2, D2, A2, B2, C1, D1, A2, B2, C2, D2, A3, B3, C1, D1, and A3, B3, C2, D2. Okay. But now what I will do, from this I can subtract R. As soon as I subtract R, what will be left? You see here, so basically this will give me what? Pi ABR cross multiplied by S. It will give me A1, B1, C1, D1, A1, B1, C2, D2, A2, B2, C1, D1, A2, B2, C2, D2, A3, B3, C1, D1, and A3, B3, C2, D2. Okay, I have taken the cross product. From that, I subtracted the original table. This was assumed that all values of AB are associated with all values of CD. Now, when I subtract R, the original relation gets subtracted. Okay, so what is the meaning of subtraction? The values which are present here but not present here. Now, A1, B1, C1, D1, it is present here. So this will not be there in my this whole expression. A1, B1, C2, D2, this will also not be present. A2, B2, C1, D1, A2, B2, C1, D1, A3, B3, C1, D1, A3, B3, C1, D1, A3, B3, C2, D2, A3, B3, C2, D2. So in this, what I will get? I will get A2, B2, C2, D2. Now, why did I got this? Because here I assumed that every value of AB is associated with every value of CD. But in actual, A2, B2 was not associated with C2, D2. So this is the assumed and this is the original. So when I subtract, I get the extra tuple. Means this is actually not associated with every value of S. If it was associated with every value of s, it would have gone in the set difference like a1 b1 and a3 b3. So here if I do pi ab, I will get the values a2 b2. So a2 b2 means what? These are the values which are not associated with every value of s, but in division operator I get the values which are associated with every value of s. So what I can do, I can say pi a comma b of r minus this value. Okay, I could have told you the formula in 1 minute also, but I wanted you to understand how it comes, so that if the question is little twisted, you do not get confused. Now just match the formula with the four options. You see here there is no subtraction. You match here pi employee id own, pi abr minus pi employee id, pi ab in the bracket, pi employee id own cross product pi brand id brand, pi abr cross product s minus pi employee id brand own minus r. Okay, so this is the correct form. So your answers will be a and b. Is it clear? Sir, if pi a b divided by pi a, it gives only pi b. Yes, so like if you have a and b attributes and like in R you have A, B, C, D attributes, and in S you have C, D attributes. So in R divided by S you will have only A, B attributes. Okay, you understood how this is derived? Yes, Pawan, good. Okay, great. Let's move on to the next question. Okay, here the answer is C. We can, here already it is given, but let's try to solve it. What does it say? Consider two relations R1 AB with tuples 1 5 3 7, and so you have R1 AB 1 5 3 7 and R2 AC with 1 7 and 4 9. Assume that RABC is the full natural outer join of R1 and R2. You want full natural outer join of R1 and R2. So when you say R1 natural join full outer R2, natural join means they will join on the common attribute, means they will join on A value. Okay, so you have A, B and C. So now, and whenever that value is not present, you even take you take null values for that, because this is full outer. Okay, so whenever right value is not present, you take right null. Whenever left value is not present, you take left null. And whenever it is matching, the common attribute is present in both of them, you connect them. Okay, so here 1 is common with 1, so this will be associated with this. So you will get 1 5 and 7. Please remember, where you get a matching, there you do not get null. So 1 5 and 1 7, 1 is common, so you take 1 5 and 7. Now you do not take 1 5 null or 1 null 7. Okay, because 1 has matched. Now for 3 there is no matching, so what you do, you take 3 7 and null, and for 4 also there is no matching, so you take 4 null 9. Okay, and what does it say? Consider the following tuples of the form. Which of the following statement is correct? So which of the following are present in this and not present in this? So 1 5 null, 1 5 null is present? No. So 1 5 null is not present, so A is not present. Then 1 null 7, 1 null 7 is also not present. Then 3 null 9, 3 null 9, no, 3 null 9 is also not present, right? So C is also not present. Then 4 7 null, 4 7 null, D is also not present, right? Then E 157, 157 is present, so E is present. 3 7 null, 3 7 null is also present. And G is 4 null 9, 4 null 9 is also present. Okay, so your option is EFG is present but not AB. Okay, in A option it says it contains AB. No, AB is not there. In B option it says it contains all. No, art contains E but not FG. This is also false because EFG are there and these are not there. So your C option is correct. Is this clear? Clear, guys? Reply quickly. Okay, great. Let's move on to the next question. Okay. So what will be the answer for this? This was asked in last year only, GATE 2023. Consider the following table named student in a relational database. The primary key of this table is roll number. The primary key is roll number. The SQL query below is executed. The number of rows returned by this query is. What will be the answer? Select star. Star means everything from student. So from this table where gender is F, and means both the queries must satisfy you. So you take gender is F. So you have three tuples. These two are already gone. And marks is greater than 65. This is greater than 65. This is greater than 65. This is not greater than 65. So number of rows returned by this would be 2 alia F70, 3 alia F80. So it would be 2. Let me cross check the answer. Yeah, so the answer is 2, I think. Okay. 2,3. Why comma 3? What they are saying? 22 3. Acha, so you are saying the tuple's name. Okay, okay. Okay, try this question. GATE 2015. Consider the following query. The number of rows returned would be. How can you solve it? Try it. I'll give 30 seconds. How can you solve this? It says select s dot student name sum p dot marks. This is the aggregate function. So there is the grouping done, and grouping would be done on student name, right? Because in select clause, if you have something which is not aggregated, it must be a grouping attribute. Otherwise, it is garbage. I hope that concept is clear. Okay. Even if you do not know that, that's okay. I mean, that's not actually okay, but that's okay for to solve this question. Okay. So select s dot student name sum p dot marks from student s and performance p, where s dot roll number equal to p dot roll number. So I want information from student. They have renamed this as s and this as p to make the query simpler. And you take cross product and you take the tuples where s dot roll number equals to p dot roll number. So 1 and 1 will be matched, 1 and 1 will be matched, 2 and 2 will be matched, 2 and 2 will be matched, and 3 and 3 will be matched. Okay. So 1 will be matched here, then 2 will be matched here, and 3 will be matched here. Okay. Then you group the students by student name. So Raj is one group and Rohit is another group. And then you return student name and sum of the marks. Now please be careful here. Don't try to calculate this sum of the p dot marks and generate all the answers. They have just asked number of rows. Number of rows will be number of groups. Number of groups will be how much? Different number of student names. There are two different student names, so there will be two groups, one with the name Raj and another with the name Rohit. So your answer will be 2. Yes, great. No, it will not be 3. The grouping is done based on name. Please correct yourself. I hope this is clear. Is it clear? Yeah, by ID it would be 3. Okay. Solve this question. A relational database contains two tables, student and performance. Again the same question, number of rows returned by SQL query is, again there is group by student name. Okay, the primary key is roll number. For performance table, the columns roll number and subject code together from the primary key. Consider the SQL query given below. Select student name sum p dot marks. This is aggregate function, so grouping is done. Grouping is done based on this value from student s performance p, where p dot marks is greater than 84. Now you see here they are not only joining roll number 1 with 1, roll number 1 with 1, they are telling student s and performance p, and here they are not saying s dot roll number equals to p dot roll number. So all the tuples will be taken, but are we going to generate that? No, not at all. How will I solve this question? You see here, in gate time matters a lot, right? So see, how will this question be solved in gate? A relational table is given, students and performance, there is student data, there is performance data. Okay, what is the said further? The primary key of student is roll number, performance is roll number and subject code. Okay, consider the query given below. Select s dot student name sum p dot marks. Here there is aggregate function, so grouping is done. Grouping is done based on this from the student and performance, where this p dot marks is greater than 84. So cross product will be taken, and all the tuples where marks is greater than 84 will be considered. Group by student name. So how many tuples will be returned? It will return the number of groups. So grouping is done based on student name. So different number of student name will be different number of groups, and that would be the number of rows returned. How many different names are there? This, all are different names, so your answer would be 5. This is how it should have been solved in gate. Okay, you do not generate everything. Okay, and so basically here, now if I tell you slowly, they are taking grouping the data. They are first taking the cross product. From that they are taking the tuples where marks is greater than 84. Then they are grouping them. They are grouping them by student name, and they are taking two values. One is the student name, that is the name of the group, and another is sum of marks obtained by that student name in all the different tuples, and that is their what they are returning. Okay, so how many different student names are there? 5. So you will have 5 different tuples. It was similar to last question. Okay, don't try to generate everything. Okay, don't go step by step. Okay, from student s performance p, now generate all the tuples. No, first look, read the question and see what is asked, and based on that you carry forward. Is this clear, guys? Please reply. Hello. As if you don't reply, it would be difficult for me to move forward. Okay. GATE 2021, it says the relation scheme given below is used to store information about employees of a company, where employee ID is the key and department ID indicates the department to which the employee is assigned. Okay, so this is the key and this is the department to which that employee is assigned. Each employee is assigned to exactly one department. Okay, so for one employee ID, there would be only one tuple. Okay, and consider the following query. The above query gives for each department in the company the number of female employees whose salary is greater than the average salary of what? Okay, so this query gives me the number of female employees whose salary is greater than average salary of someone, but of what, that is asked in the question. So let's read. Select department comma count. Now why is there count? Because it gives the number of female employees who's in each department. So grouping is done based on department. Here you can see. Okay, so your answer will be something like this: department ID and count. Here the ID of the department will be given, and here some count will be there. Means this is the number of female employees whose salary is greater than average salary of something. Now that something we have to tell from employee table. So this is clear, this is clear, group by is clear. Where gender is female, yes, we are giving information about female, and salary is greater than. Now greater than average salary of what, that is asked in the question. So greater than this, what is that? Select average salary from employee. So they are taking the average salary of each and every employee. Means employees in the company, greater than average salary of employees in the company. Okay, all the employees, because here they are considering all the employees, there is no condition. So B option would be the correct answer. Why C? Here they are taking the female employees whose salary is greater than what? Greater than the average salary. Now average salary is counted based on what in this subquery? They are considering all employees. So whose salary is greater than average salary of what? Of all the employees in the company. Answer would be B, guys. Please, if you have any doubt, ask me. I hope you got the point. Okay, great. Other people who wrote C, is this clear? The answer would be B. Okay, great. Try to solve this question. Consider the following database table, name top scorer. Consider the following SQL query. The number of tuples returned by the above SQL query is, again they are asking the number of tuples. Okay, so what they are doing is they are selecting something from this table as this, means they have renamed this top scorer table as TA, and from that table they are taking the player name. So they are selecting this value where TA dot goals is greater than. So this is the where condition. In that there are two things, that TA dot goals is greater than this and TA dot goals is greater than any. So they will consider the players from this table whose goals are greater than all the players returned in this subquery, and any means at least one player whose goals are greater than at least one player in this, okay, subquery. Now let's go here. Select tb dot goals, means for this subquery they have renamed the table as tb dot goals from top scorer as tb, where the country tb dot country is Spain. So here they will return the goals of all the players who are from Spain. From Spain there is no value. If there is no value, this is empty. If this subquery is empty, then goals greater than empty means here it is all, means it is already true because this is empty. So here no tuples will be rejected, all will be taken. Now the second query, and TA dot goals is greater than any means at least one tuple. Okay, select TC dot goals. Here they have renamed the table as TC, from top scorer as TC, where TC dot country is Germany. For Germany we have this and this. So what they are saying is this query will be true for every tuple. They are saying select the player name whose number of goals is greater than any of the players of Germany. Now any of the players means, if I check for a particular player, if their goal is greater than the minimum number of goals of a German player, then they will be included. Basically, what does this say? It says that include the players whose score is greater than any of the players of Germany. Means it is either greater than 16 or greater than 14 or greater than 11 or greater than 10 or greater than 10. I'll simply check the players whose score is greater than 10 only. So what all answers will I get? See, 1, 2, 3, 4, 5, 6, 7. There will be 7 tuples where the number of goals is greater than 10. So the number of queries written, number of tuples written would be 7. Clear? Goals in range of 16 to 10. No. See, this subquery will return what? It will return greater than any of the values from this table. Now this table R. Now this table R contains what? It contains the goals value. And what will be the values? The players who are from Germany. So it is 10, 10, 11, 14 and 16. So 16, 14, 11, 10 and 10. Okay. Now the outer query, they have renamed this table as TA, and they will select the name of players whose score is greater than any means if the score is greater than even one player from here, they will consider it. So let's say someone's score is 17, it is greater than 16, okay, well and good. Someone's score is 12, it is less than 16 and 14 but greater than 11 and 10. Someone's score is 11, it is less than equal to 16, 14 and 11 but greater than 10, so we will consider all three of them. So for easiness, what we can do is here, since it is any, means we will get the players names whose goals is greater than any of these values. Any of these values means either it is greater than 16 or greater than 14 or greater than 11 or greater than 10. Now if it is any, then can I say if the goal is greater than 10, I will consider it? Because if the goal is greater than 16, it will obviously be greater than 10, no need to check. But if a goal is less than 10, it is obviously less than other values also. So simply check if the goals is greater than the minimum value here. Why? Because here it is said any. If this was all, then we would have checked it with 16, because if the number of goals is greater than 16, then it would be greater than all. But here, since it is any, we are checking greater than 10, and there are 7 tuples, so your answer would be 7. Clear? Okay, great. Again, here they are asking about the output. Consider database that is the relation schema EMP, employee ID, employee name and department name. An instance of the schema and an SQL query are given below. What would be the output? Okay, so what they have done is, let's see. Select average ec.num. So they have selected average value of num from the ec table. Okay, now what is ec? Here it is not there, so it must be have defined further. From ec means ec is the table where department name comma num is present in. Okay, and now this is the subquery. What does it say? Select department name comma count of employee ID as ec department name comma num from employee group by department name. So let's solve this inner query first. They are selecting department name and count of employee ID as ec department name and num. So they are grouping the tuples by department name and they are returning department name and employee IDs count. Okay. So in EC table, I will have department name and count of employee ID. Okay. So I will have what? How many department names are there? XYA. Sorry, this is employee name. Department name is AA. So there are AA. And how many employee IDs are there? 4 different values. So I will say 4. AB. There are 3 different values. Then AC. There are again 3 different values. AD. There are 2 different values, and AE there is only 1 different value. So they are telling this is the department name and this is the count of employees in that. Now from this inner query we get what? We get the EC table. Okay, they have renamed this table as EC, and what they have said, calculate the average of ec.num. Now they have renamed it, so they have renamed this count as num. Okay, and select average of this from this table. So what will be the average value? 4 plus 3 plus 3 plus 2 plus 1 divided by 5. Total divided by total different tuples. 4 plus 3 is 7 plus 3 is 10. 10 plus 3 is 13. 13 divided by 5. This will give me what? 5 2s are 10. 3 0. 5 6 are 30. So your answer would be 2.6. Means in last question, if any of the condition is true, any subquery, it will be considered as a result. Yes, Rohil. In the last question, since it was any, so if that condition is true for any subquery, it will return true. Okay. And hence what we did was we compared it with the minimum value. because if it is greater than minimum value, we will consider it no matter whether it is bigger than maximum value or not. Okay, is this clear? 2.6. Okay, sir, in any if two condition is true, so which query will execute? No, any means if it is true for even three conditions, three queries, it will return one only. Okay. So for example, your 16 number of goals is greater than 10 as well as it is greater than 11. That doesn't mean 16 will come twice. It is just a checking condition whether it is greater than any. Any means at least one. Okay, and if it is all, it means it should hold true for all the subqueries. It must relate with all the subqueries. But in our answer, that tuple will be considered once only. It is just checking that whether it is greater than any of the values. Yes, in case of maximum, in case of all, you need to compare with maximum value with respect to this question. Okay, nothing generalizing. But with respect to this question, if it was all, you compare it with maximum value. Because if it is greater than maximum value, it would be greater than other values as well. Now clear? This 2.6 is clear, guys? Okay, great. Try to solve this question. GATE 2020. Consider a relational database containing the following schemas. The primary key of each table is indicated by underlying constituents field. So S number, P number, S number, and P number. And this query is run. The number of rows written by this query is. So how can you solve this question? Select S dot S number and S dot S name. Now, first of all, let's see how they have renamed from suppliers S. So this they have renamed as S, and catalog C. So this they have renamed as C. Select S dot S number and S dot name. So you select S dot S number and S dot name. Okay. From this, so they have taken the cross product, and after taking the cross product, they are only taking the values which match this condition, where S dot S number is equal to C dot S number. So this S1 will match with this, and this will match with this, and this will match with this. S2 will match with this, S2 will match with this, and S3 will match with this, it will match with this, it will match with this, and it will also match with this. Okay, because they are only taking the tuples where S dot S number equal to C dot S number. Okay, and one more condition must satisfy. Cost is greater than some value. Okay, so this cost must be greater than some value. What is that? Select average cost from average means aggregate function. Aggregate function means grouping is done. Group by P number. Select average cost from catalog table. From catalog table, select average cost where P number is P4, where P number is P4, and group by P number. Now you see here they are taking only one P number, and they are also saying group by P number. Okay, so basically there will be only one value for P4. Now for P4, what is the cost? 250 and 200. And what is the average of 250 and 200? 225. 200 plus 250 divided by 2 is 225. So we will select the tuples whose cost is greater than 225. Okay, so S1 was so this tuple will not be there, this will not be there, this will not be there. Okay, and one tuple is there, second tuple is there, third tuple is there, fourth tuple is there. There are four tuples. Now here also S2 will relate with this S2, and S2 will relate. Okay, so this tuple S2 P5 250, S2 P5 250 will relate with S2 Balaji Furniture and Bangalore. Okay, will relate with S2 Balaji Furniture and Bangalore. This is the first tuple. Then S3 will relate with this S3 because the cost is greater than 225. This S3 will also relate to this S3, and this S3 will also relate to this S3. Okay, so it will be S3 P1 250 and S3 Premium Furniture Chennai. Then S3 P5 300 and S3 Premium Furniture and Chennai, and S3 P4 and 250 and S3 Premium Furniture and Chennai. So there will be 4 tuples. So the number of tuples returned will be 4. Yeah, great. Clear? Shall we move to next question? Okay, great. Again, the number of rows asked written by the SQL query GATE 2022. Consider the relational database with the following 4 schemas and their respective instances. Okay, how many rows will be written by this query? What does query say? Select star. Star means everything from student as S. So they have renamed this table as S. Where not exist. Not exist means, see, exists will return true if it is present in that, right? And not exist will return true if this is empty. Okay, so select C number from course number where D number is D01. Select C number from course number where D number is D01. So you select C11 and C12, except select C number from register where S number equal to S dot S number. Okay, so you select C number from register where S number is equals to S dot S number, and here there is except. So all the values which are present here will not be present here. Okay, and not exist will return me true where when this will be empty. When this will be empty, when this C1 C2 are also present in this query. So C1 C2 except C1 and C2 will give me empty, and when this will be empty, my non-exist will be true. Now when C1 and C2 will be present in second query, it is select C number from register. So here I want to select C1 and C11 and C12. They are present here, they are present here, they are present here, and it is present here where S dot S number is equal to S dot S number. Okay, now it means for all those S values where both C1 and C2 are present, that will be here. So C1 and C2 are present for S1, S01. They are present for S02. It both are not present, C11 and C12. Okay, for S04 both of them are present, and for S5 they are not present. For S3 they are not present. So for S01 and S04, C11 and C12 both are present. So when both are present, this query gives me what? This query gives me C11 and C12. For S01 and S04, where S number is equal to S dot S number, will match for C11 and C12 both, because for those values C11 and C12 both are present. Now this except this will return me empty, and hence not exist will be true. They will be true when I have S01 and S04. Okay, so from student table I will get S01 and S04. Okay, so there will be 2 tuples. Is this clear? Is this clear, guys? Okay, great. One more person at least. Is this clear, guys? Then I'll move on to next question. If condition is true and it return except, so it will take If condition is true and it return except, so it will take. See, here it is not exist. Not exist will return me true when this is empty. When will this be empty? When the tuples which are present here are also present here. So this except means what? Set difference. The values which are present here but not present here. But I want this to be empty in order for this to be true. When will this be empty? When the tuples present here are also present here. Here C11 and C12 are present. So here also I want C11 and C12 both are present. Now here they are selecting C number when S number and S dot S number matches. When S number and S dot S number matches. Now for which S number, for which student number will I get C11 and C12 both? It is for S01 and S04. For both the students I will get C11 and C12 both. So hence C11, C12 and C11, C12, if I take the set difference it will be empty. If it is empty, not exist will return me true. If it will return me true, then this select will be taken, this tuple will be taken, otherwise not taken. So for which students the tuples will be taken? For S01 and S04. Is it clear now? Okay, great. Okay, I think this should be the last question for SQL and relational algebra and all. Database table name loan records is given. What is the output of the following SQL query? Okay, we need to tell what are the output for the following SQL query. Select count. Count means total number of tuples from. So from this relation, now this is the inner relation. Here it say they say select borrower and bank manager from this loan records as S. So they have renamed the table as S, and from that they have taken borrower and bank manager. Borrower and bank manager. So what will be the values that they will get? Borrower and bank manager. So Ramesh and Sundararajan, Suresh and Ram Gopal, Mahesh and Sundararajan. Okay. Natural join. I am doing natural join between this and one more. This is selected as T. They have renamed it as T. So let me write this table as T. Bank manager and loan amount. This is bank manager and loan amount. Okay. What will I get? Sundararajan 10,000, Ram Gopal 5,000, Sundararajan 7,000. Now they have done natural join, and count means how many tuples will be there in the natural join. So when you do natural join is between common attributes. So this Sundararajan tuple will be associated with this Sundararajan tuples, and this will also be associated with this because the common attribute is bank manager. This Ram Gopal will be associated with this Ram Gopal only, and this Sundararajan will be associated with this Sundararajan and this Sundararajan. So this will be associated with two tuples. Ram Gopal will be associated with one tuple, and this Sundararajan will again be associated with two tuples. So the total number of tuples would be 5. Yeah, great. Clear, guys? Let's move to next thing. Okay, clear? Okay, great. Now, there are some questions based on functional dependencies and normalization which I want to discuss, but I do not want to jump directly. So I'll go through a little bit of theory, but they are in the form of numericals only. Okay, so we will go quickly. We want to check if these two set of functional dependencies are equivalent or not based on this relation. So how can we do that? So what I can do it, I can calculate the closures of the left hand side of functional dependency set 1 with the help of functional dependency set 2. If I can find all these dependencies, then I can say functional dependency set 1 is a subset of functional dependency set 2, because the expressive power of functional dependency set 2 allows me to generate all these functional dependencies which are present in functional dependency set 1. So I will find v plus, I will find vw plus, I will find y plus, and I will find y plus, but I will find it with the help of this. So v plus is what? V gives me vwx, and so it will give me vwx. Vw plus will give me what? Again vwx. Y plus, y will give me yvz, and v will give me vwx. So y will give me vwxyz and vwxyz. Now if I see here, v gives me w is satisfying here, yes. Vw gives x, vw is giving x, yes. Y is giving vx, y is giving everything, so these two are also true. So I can say functional dependency set 1 is a subset of functional dependency set 2. Okay. Now what I will do is, I will find the closures of attributes of the left hand side of functional dependency set 2 using functional dependency set 1. So I will find v plus and y plus. V plus and y plus, but using what? Using this. So v plus is v gives me w and vw gives me x. See, v plus will give me v gives me w. Now vw gives me x. I already have vw, so I can also get x. So it will be vwx. What will be y plus? Y will give me z and it will give vx. So y can give y, z, vx. V can also give w. So from y I can get everything. Now v gives me wx, v gives me wx is there, yes. Y gives me vz, y gives me vz is there, yes. This is gives me, okay. So from this I can say functional dependency set 2 is a subset of functional dependency set 1, because the expressive power of functional dependency set 2 is also present in functional dependency set 1. Now if functional dependency set 1 is subset of 2 and 2 is a subset of 1, then can I say functional dependency set 1 equals to functional dependency set 2? Okay, so this is for this set. Okay, so what can it be different possibilities? One is functional dependency set 1 is same as functional dependency set 2. Another is set 1 is a subset of set 2, and set 2 is not a subset of set 1, or set 2 is a subset of set 1 and set 1 is not a subset of set 2, and the fourth one is they are not equal. These four possibilities can be there, and here it will be this. Clear this? Okay guys, clear? Please reply. Okay, great. Let's move to next. Now I want to find the canonical form of functional dependencies for this set. Okay, so how can we find canonical form? So you see here, canonical form means minimal form. Minimal form means there should not be any redundancy. Now redundancy can be on three sides. One is on right side, one is on left side, and one is the whole functional dependency is redundant. Okay, so I'll give you an idea and then you can solve it by yourself. We'll move further. I'm not going to solve this completely. So how can you do this? So see, first of all, the redundancy can be on right side. So how can I remove that redundancy? First of all, if A is giving me BC, means if I have the value of A attribute, I can get the value of B attribute as well as C attribute. AB gives me C, means if I have values of attributes of A and B both, then I can get the value of C. Okay, here it says if I have the value of attribute A, I can get value of attribute B and value of attribute C. So this can be broken down into A gives me B and A gives me C, because A can give B as well as C. But this cannot be broken down into A gives me C and B gives me C. Okay, because A, B together are giving the value of C. So individual doesn't guarantee. Okay. So first of all, how do you remove the redundancy on the right hand side? You just break them. So B gives me A, C gives me A, C gives me B, C gives me D, AD gives me B, and AD gives me C. Okay, so right hand side, now there can't be redundancy because there is only one attribute. Now, so right hand side redundancy is removed. Now, how can you get left hand side redundancy? Or if you want complete redundancy, okay, so your right hand side redundancy is gone. Now you look for complete redundancy. So how can you get complete redundancy? You start moving from top to bottom. You can go in different order also. Okay, depending upon your order, your canonical form will be different. For this set of functional dependency, there can be multiple canonical forms. Okay, so in general, you start going from top to down, and what you do is you find the closer set of left hand side. So you find B plus twice. Once you find B plus considering all the functional dependencies, once you find B plus without considering this, without considering B gives me A, if both of them are same, it means this functional dependency is redundant. Because even with considering this functional dependency and even without considering this functional dependency, you are getting the closer set of attributes of B same. It means this is redundant. In that way, you can remove the complete functional dependency redundancy. Once you do that, how can you remove the left hand side redundancy? So for example, just a random take. Okay, let's say finally you are left with C gives me B, C gives me D, AD gives me B, and let's say AD gives me C. Okay, finally you are left with this. Okay, you need to solve it. I'm just randomly taking. So your right hand side redundancy is gone, complete redundancy is gone. Now for left hand side redundancy, what you can do, see here there is no left hand side redundancy, it is single attributes, they can be present here only. So if I want to find whether this is a redundancy or not, what I will do is I will find AD plus, I will find A plus, and I will find D plus. If AD plus is same as A plus, it means D is redundant. If D plus is same as AD plus, it means A is redundant. Both will not be same. Okay, because at least one should be not redundant, because if the complete is redundant, it would be removed in second step only. So if A plus is same as AD plus, then D is redundant, you can remove D. If D plus is same as AD plus, A is redundant, you can remove A. And in that way, your left hand side redundancy will also be removed. Clear? And when you remove all redundancies, right hand side, a complete redundancy, and left hand side, then you will get the canonical form. Okay, clear? I just lost my connection. Can someone reply again? Is it clear? Okay, let's move further. So there are some more questions on canonical form. Okay, let's solve this question. Guys, what would be the answer for this question? The following functional dependencies hold true. Which of the following is irreducible equivalent for this functional dependencies? You have to find canonical form. Okay. So what I can do, first of all, remove right hand side redundancy. So I will say V gives me W, VW gives me X, y gives me v, y gives me x, and y gives me z. Okay, now I need to find the complete redundancy, so I can find v plus. Okay, and v plus considering this and not considering this. Okay, so let me find it out only. So I'll find v plus considering all this. Okay, so it will give me v w, then vw gives me x, and I will find v plus without considering the first functional dependency, so it will give me v only. So this is not redundant. Then vw plus considering this will give me vwx, and not considering that would give me v and w, so this is also not redundant. Then y gives me v, so y plus is yv, v gives me w gives me x, and y also gives z. So you have all the attributes. And now not considering y gives me v, if I can calculate y plus again, it will be not considering this. Okay, so it will give me y, it will give me x, it will give me z, and other than that I cannot get, right? So this is also not redundant. Now y gives me x, so y plus would be again vwxyz considering it, and y plus not considering this, y gives me x will be, y will give me z, y will also give me v. I can get z from here and v from here. Okay, v can give me w and x both, so these two are same. It means this is redundant, so I can remove it. Now y gives me z, it will give me yz, y plus would be yz. Now y gives me v, v gives me w, w gives me x. Now without considering the last one, y will give me v, v will give me w and x, but I will not get z, so this is also not redundant. So y gives me x is redundant, so y gives me x is redundant. Okay, y gives me x is redundant. What am I left with? V gives me w, vw gives me x, and y gives v, and y gives z. Let me just see. V gives w, v gives x, v is not giving x, means till now. Y is giving me z, y is giving me v. Y, v gives me w, w gives me x. Okay, and y gives v, and y gives z. So this and this are present in both. I have to check only about the second one. Okay, so either v is redundant or w is redundant. So how can I find left hand redundancy? I will find vw plus. Vw plus is what? Vwx, right? What is v plus? V plus is vw. And what is w plus? W plus is, and once you have vw you can also get x, right? And what is w plus? With w you can get only w, right? So v plus is same as vw plus. It means w is redundant. If w is redundant, we can remove it, so your answer would be a. Okay, because you're without just a second, I am getting something wrong. Vw plus is vwx, because here v plus will give me vwx both, here also v plus will give me vwx both. uh, your w plus should be equal to what? If you find w plus, it is only w, right? But if you get vw, it is vwx, so w must be redundant, right? Can someone check the answer for this? Following functional dependencies, GATE 2007. Okay, A is the correct answer. Okay, A is only correct, as I said, because here V plus is giving me VWX and W plus is giving me W only. So if I take VW plus, it is same as V plus, so W is redundant, so your A option is correct. Is this clear? Please reply, guys. I don't see any reply in last some time. Guys, if you don't reply, it would be difficult for me to move forward. Is this clear? If not clear, then let me know. I'll explain again. If clear, just write yes. Okay, let's move further. Now this is about normalization. Okay, so let me just quickly go through some normalization concept. So if you have some set of functional dependencies for a particular relation R, then R is said to be in 2NF. See, 1NF is trivial, okay? If you have atomic values in your relational table, then it is, and all the column names are different, etc., then it is already in 1NF, okay? So we do not check for it. In 2NF, there should be no functional dependencies which are partial dependencies, okay? There must be no partial dependencies. So what is the meaning of partial dependency? If alpha is a prime attribute and beta is a non-prime attribute, and if alpha determines beta and this is not a key, this is a part of the key, then this is called partial dependency. Due to this, you get redundancy in your data, and hence if there are partial dependencies, the table is not in 2NF. Okay, for 3NF, the table must be in 2NF and there must not be any transitive dependencies. Not transitive dependencies. What are transitive dependencies? If there is a functional dependency alpha to beta, and if alpha is a non-prime attribute and beta is also a non-prime attribute, then this is called a transitive dependency. So there should be no functional dependencies like this. Okay, due to this also what happens, redundancy occurs. Okay, also what are prime and non-prime attributes? Prime attributes are those attributes which are a part of any candidate key. Remember, any, not all. It might be a part of all the keys, but it must be a part of at least one key. And non-prime attributes are the attributes which are not a part of any candidate key. Okay, not part of any candidate key. Okay, so this is 2NF, 3NF. How can you check for 3NF easily? There are two conditions. One is if alpha is a super key or beta is a prime attribute for all functional dependencies, then you say your table is in 3NF. Why you can check two things? Because what is the meaning of 3NF? The table must be in 2NF and it must not have transitive dependency. Now what are transitive dependencies? When you have alpha to beta and alpha and beta both are non-prime. So non-prime determining non-prime. If alpha is a super key, it means it is not a non-prime. So if this condition is true, then the function either this condition is true or this is true, or beta is prime, so it is not prime. So if any of the one condition is true for all functional dependencies, I mean for all functional dependencies, at least one of the two condition must hold true, then we say that our table is in 3NF. For BCNF, for all functional dependencies alpha to beta, alpha must be a super key. Okay, there is only one condition. Okay, so if this is true, your table is in BCNF. So if a question is given where you are given a table and asked to check in which normal form the table is, you will start by checking from BCNF, then come to 3NF, and then come to 2NF. Okay, just a second, guys. Okay, so I hope this much is clear. Okay, so let's look at the questions now. So what will be the answer for this? It says consider a relational table R that is in 3NF but not in BCNF. So it is in 3NF but it is not in BCNF. Now for BCNF, alpha must be a super key for all functional dependencies alpha to beta. So if it is in 3NF but not in BCNF, so there must be a functional dependency alpha to beta where alpha is not a super key, right? Which of the following statement is true? Okay, R has a non-trivial functional dependency x to A where x is not a super key. If it is not a super key, it means it is violating BCNF, and A is a prime attribute. Okay, so it is not a super key and A is a prime attribute. Why should be in prime attribute? Because it is in 3NF. Are you getting my point? In 2NF, we had alpha to beta where alpha was a prime attribute and beta was a non-prime attribute. In 3NF, so there must not be any partial dependency, right? And in 3NF, there must not be any transitive dependency. So non-prime to non-prime must not be there, right? But in 2NF and 3NF, there was no condition where you have functional dependency alpha to beta and this is a prime. That they are not telling not to have in 2NF and 3NF. So in 2NF and 3NF, you can have alpha to beta where alpha is not a super key and beta is a prime attribute. So A option is correct because it must also be in 3NF. Now, look here, R has a non-trivial functional dependency where X is not a super key and A is not a prime attribute and X is not a proper subset of any key. So that means it is a transitive dependency. If it is transitive dependency, it is not in 3NF. So this option is false. R has a non-trivial functional dependency where X is not a super key and A is a non-prime attribute. If A is non-prime attribute, then it means and X is a proper subset of any key, means it is prime to non-prime, means this has partial dependency, so this is also not true. A cell in R holds a set instead of an atomic values. If it holds a set, it is not in 1NF only. So your option A is correct. Okay, let's move further. Very simple question. Suppose the following functional dependencies hold on relation U with attributes this, then which of the following functional dependencies can be inferred from the above functional dependencies? So what we can derive from this? From this we can derive P gives me Q, P gives me R, and rs gives me t. We can break on the right hand side. So which of the following is present? T gives me r. Okay. Look at this question. Which of the following statement is true? Every relation in 3NF is also in BCNF. Not necessarily true, right? We just now saw an example. A relation R is in 3NF if every non-prime attribute of R is fully functionally dependent on every key of R. If every non-prime attribute of R is fully functionally dependent on every key of R. Now, when do we say it is in 3NF? If for all functional dependencies, either alpha is a super key or beta is a prime attribute. So even if alpha is not a super key but beta is a prime attribute, then in that case also we say it is in 3NF, because one condition is holding true. Here it says that every non-prime attribute of R is fully functionally dependent on every key of R. Okay, that is true, but other than that, you must also hold this. For every non-prime attribute of R, it is fully functionally dependent on every key of R. Okay, here I think the mistake is every. It is not dependent on every key. It must be dependent on at least one key. Okay, like if there are three keys, it is not necessary that every non-prime attribute will be dependent on all three keys. Okay, every relation is BCNF is also in 3NF. Very obvious. No relation can be in both BCNF and 3NF. Rubbish, because if a relation is in BCNF, it is also in 3NF. Okay. Yeah, C is correct. What will be the answer for this? Relation R has 8 attributes. Fields of R contains only atomic values. Now, fields of R contains only atomic values means the table is in 1NF, that we have to assume. Okay. These are the functional dependencies, is a set of functional dependencies, so that F plus is exactly the set of functional dependencies that hold for R. Okay. How many candidate keys does the relation R have? So how can we find the candidate keys? Candidate keys means the minimal super key, right? How can we find minimal super key? See, what is a candidate key? If I have a set of attributes P, and if I say P plus, if this is a candidate key, it will give me all the attributes of my relation, because key can identify all the attributes of the relation. So if I want to find how many candidate keys does the relation have, first of all, in my candidate key, those attributes will definitely be present which are not present on the right hand side of any functional dependency. See, understand. G is present on the right hand side, BC is present, CFH is present, A is present, EG is present. So A, B, C, D, E, D is not present, I think. A is present, EG is present, CFH is present, BC is present, and G is present. So D cannot be determined by any attribute. If D cannot be determined by any attribute, then D will definitely be a part of my key, because my key can identify all the attributes. And if D is not there on the left hand side, it will also not be there on the right hand side. So D will at least be there. So I'll start with D and different combinations of D. Okay. So I'll say D plus. Let me solve it here. So D plus will give me what? Until I find all the attributes, I'll take different combinations. So D plus will give me only D. This is not a key. Now I will say DA plus, DB plus, DC plus, DE plus, DF plus, DG plus, and DH plus. Okay, so DA plus. Now D can give me D and A can give me A. A can also give me BC. Then what else can I get? From B I can get CFH. So C I already have. So I can get F and H. From F I can get E and G. So I have A, B, C, D, E, F, G all. Right? I have all the things. So DA is a candidate key. Now I cannot add any more attributes to DA, because that will not be a candidate key. Candidate key means minimal key. DB plus, D will give me D and B. Now from B I can get CFH. From F I can get EG. What is left? A is left. Can I get A from somewhere? If I have E, I can also get A. So A, B, C, D, E, F, G, H. This is also a key. DC plus. DC plus will give me D and C, trivial. Then what else can I get? I cannot get anything. So this is not a key. Then DE plus. D and E can give me D and E can give me A. Now DA is a key. I got D and A. So I will get the remaining attributes, obviously, no need to check. So DE is a key. Now DF. DF will give me DF. Now from F I can get EG. And DE is a key and D and E are present. So this will also give me the remaining attributes. So DF is a key. DG. DG will give me D and G. Then further I cannot get anything. DH. DH will give me D and H only. No, nothing further. Okay. So I have got DA, DB, DE and DF. DA, DB, DE and DF. Till now I have got these keys. DC, DG and DH have not satisfied. So I can make the subset larger. So with C, I can attach G and H. I cannot attach A, B, E or F, right? Because that will not be a candidate key. If with DC, if I attach A, then DA is a candidate key. So DCA would be a super key. This is not a candidate key, okay? So with DC, I can attach G and H only. So I can say DCG plus, DCH plus, and I can also combine H and G. So DGH plus, okay? So if I find here, DCG will give me what? Let me write it here. DCG will give me DCG. Then other than that, from DCG, I cannot get this, cannot get this, cannot get anything. Okay. So this is not a key. DCH will give me DCH. Then from CH, I can get G. Then from there, I can get nothing. So I will stop here. And DGH will give me D, G and H only, nothing else. So I will stop here. Now I can take one more combination, that is DCGH plus. This will give me DCGH and anything further. CH can give G, nothing else. Now I cannot get anything further. Okay, I cannot get A or B or E or F. Okay, so I get 4 keys. So the number of candidate keys is 4. Yeah, 4 is the 54B. Yes, for 54, B is the correct answer. For 55, the relation R is in. It is in which normal form we want to find. Okay. So what I said, first you find for BCNF, then you go for 3NF, then you go for 2NF. Okay, because if a table is in, if a database is in BCNF, it is obviously in 3NF, 2NF and 1NF. So what is BCNF? For all functional dependencies alpha to beta, alpha must be a super key. What are the keys? DA, DB, DE, DF. Is CH a super key? No. So it is not in BCNF. Now 3NF, alpha gives me beta, alpha must be a super key or beta must be a prime attribute. Is alpha a super key? No. Is beta a prime attribute? No. Because prime attributes are the attributes which are a part of any candidate key. G is not a part of any candidate key. So it is not in 3NF also. So 2NF. For 2NF, there must not be any partial dependency. Means partial dependency means this is a part of the key prime attribute and this is non-prime attribute. Okay. Now E gives me F gives me EG. So I can write F gives me G and F gives me E. Now F is a prime attribute because it is a part of the key and G is a non-prime attribute. So this is a partial dependency. So it is also not in 2NF. So the answer is it is in 1NF but not in 2NF. Okay. Yeah. Good, Pawan. Correct answer. Okay. Let's move further. I hope this was clear. Just give me a thumbs up. Write yes. Okay, great. So this was asked in GATE 2016. A database of research articles in journal uses the following schema. The primary key is volume, number of page, start page, end page, and the following functional dependencies exist. The database is redesigned to the following scheme. What is the weakest normal form that the new database satisfies but the old doesn't? Okay. So first of all, we'll find the normal forms for old and new. Okay, so how can we find? See, I can write this as A, B, C, D, E, F, and G. Okay, so primary keys A, B, C, D. This is A, B, C, D. A, B, C, D gives me E. A, B gives me F. A, B, C, D gives me G. Okay, this is A, B, C, D, E, G, and this is A, B, and F. Okay, so I can say that the primary key is what? Primary key is A, B, C, D, right? What are the functional dependencies in the old? If I write old, it is A, B, C, D gives me E, A, B gives me F, then A, B, C, D gives me G, right? And yeah, there are three functional dependencies. Okay, so what is the normal form? Is it in BCNF? For BCNF, alpha must be a super key. This is not super key, AB. So BCNF is not true. Okay, then 3NF. Either alpha must be a super key or beta must be a prime attribute. What are the prime attributes? A, B, C, D. Okay, so alpha is not a super key, neither beta is a prime attribute. So this is also not in 3NF. For 2NF, there must not be partial dependency, means alpha is a part of the key and beta is non-prime attribute. This is a part of the key and this is non-prime attribute. So this is a partial dependency. So it is neither in 2NF. So old schema is in 1NF. Okay. Now for the new, they have designed it in what? They have designed it like this. So R1 contains A, B, C, D, E, and G, and R2 contains A, B, and F. Okay. Now, if they have A, B, and F, then from the old functional dependency, I can say it will satisfy A, B gives me F from here. And here I can say A, B, C, D will give me E, and A, B, C, D will give me G. Right? So this would be two different relations with two different functional dependencies, right? This is the relation. Okay. So here is this in BCNF. What is the meaning of BCNF? For all functional dependencies alpha to beta, either alpha must be a super key. Now this is a super key for this table. So this is a super key, and here this is the super key. So the new table is in BCNF. Okay. Now what the question asks? What is the weakest normal form that the new database satisfies but the old does not? Now weak new satisfies 2NF, 3NF, and BCNF, which the old does not. But out of this, which is the weakest? Weakest is 2NF, satisfied by new but not by old. So your answer will be 2NF, not BCNF. Okay, be clear. Don't make such mistakes. Is this clear? Is this clear, guys? Okay, great. Let's move further. Okay, so consider a relation with the following three functional dependencies. The number of super keys is. Now whenever you are given this kind of question, first of all you find the candidate key. So the candidate key is what? How you will get? First of all, you will take the attributes which are not there on the right hand side. So you will try with AB plus. AB plus is what? AB can give you AB. It can also give you C. Then BC can give you D, and C can give you E. So you got all the attributes. So AB is the candidate key. So if your key is there, then A and B will definitely be there. C, D, and E, you can either take it or not take it. So there are two choices for all three of them. So total there will be 2 keep power 3 super keys, and hence the number of super keys will be 8. Is this clear? Is this clear, guys? Okay, let's move further. Okay, so we have started. Now we are coming to indexing. So I hope you know the basics. So basically, why do we do indexing? To make faster retrieval of data. Okay, and we study three types of indexing. One is the primary indexing, another is the clustering indexing, and third one is the secondary indexing. Okay, so what is the basically meaning of indexing? That let's say you have a lot of data. Okay, these are different records. Okay, so what you do is, now in each record, let's say you have a student record. Okay, so there will be roll number, there will be name, there will be age, there will be phone number, there will be address, and a lot of things. Okay, so you make a index data structure where you have some key attribute. Okay, this is called indexing attribute, based on which you make the index. Okay, and you have a pointer to the block which is containing the information with respect to this attribute. Okay, for example, this is roll number 3. Then you will point to a block. Remember, not a record. You will point to a block. A block is a, there is a block on the disk, and in one block there may be multiple records. Okay, so you will point to a block which will contain the record having the attribute value 3. Okay, the indexing attribute 3. Now primary indexing is basically when the indexing you are doing, when the indexing which you are doing, that indexing attribute is key, as well as the data is ordered on key. Okay, as well as the data is ordered on key, right? Means the data is sorted with respect to that key value. Clustering means the indexing attribute which you take is not a key, but the data is ordered based on the indexing attribute. Okay, and when we talk about secondary indexing, it is here the indexing attribute is not a key, as well as the indexing the data is not ordered based on that indexing key attribute. Okay, so if we talk about primary indexing, then see what will happen is, let's say this is my data. Okay, and this is the indexing attribute, and for primary indexing it is sorted based on this attribute, right? This is your data. Okay, main data. Now let's say your roll number starts with 1 2 3 up to, let's say, 20 goes in first block. First block of the disk can hold 20 records. Okay, then 21 to 40 will go in the second block, then 41 to 60 will go in the third block, and so on, right? Now the indexing index structure which is built will only contain the first values of all of them. Okay, so that the index structure is small. If index structure is also big in itself, then what is the point? So it will contain roll number 1 and a pointer to this block. it will contain roll number 21 and a pointer to this block. It will contain roll number 41 and a pointer to this block. It will contain a pointer 61 and a pointer to this block. Then pointer 81 and roll number 81 and pointer to this block, and 101 and a pointer to that block. Okay, so here the values are less. Now let's say this is also sorted. Here the values are less. For each block you have one record. Okay, now let's say if you want to find something, for example, you want to find the data of roll number 38. So what you can do is you can apply a binary search on this. Okay, now this is 61, so the pointer to which, so in binary search what we do, first we take the middlemost value. So middlemost value is 61. Now 61 will point to a block where roll number starts with 61, so obviously other values will be greater than 38. So you do a binary search on the top part. Here the middle value is 21, so 21 will point to a block which will contain the values starting with 21. Okay, so what you do is, so your value 38 may be present in this block or maybe in below blocks, right? Because 38 is greater than 21, but this block starts with 21. Okay, so 38 may be present here or may not be present here. So how can you check that? You check with the next starting point. Next starting point is 41, so you can be sure that 38 is present in the pointer. It is present in a block pointed by this pointer only. So you directly go here, and then here you can access the data. Is this clear? Is this clear, guys? Okay, so let's solve one question based on this. So for example, if for data file number of blocks is 9500, okay, see, not number of records, it is saying number of blocks, and each block size is 4 KB, and the ordering key field value, this is ordering key field, its length is 15 bytes and the block pointer is 6 bytes. Find the number of disk block accesses required to get the data with and without primary indexing. Okay, now if primary indexing is not done, this is still ordered data, right? So you can do binary search on this 9500 blocks, right? So you can say log base to 9500, okay, whatever value you get it, right? But if you use primary indexing, then see, for the index structure you will have how many records? It will be equal to number of blocks. So for index structure, this is index structure. Okay, just a second. For a data file, the number of blocks is 9500, right? So you will have 9500 records here. So each record will contain two things. One is the ordering key field value, that is 15 bytes, and another is the block pointer, that is 6 bytes. So total 21 bytes, right? Now there are total 21 bytes. So in one block, how many records can be there for index structure? For index structure, how many records can be there? You can say, so basically what you can do here is, this can also be divided into blocks. So first block will contain the information, let's say from 1 to 61. The next information will be from 101 to something else. Okay, so when you do binary search, and if your current blocks contains information from start I to end I, and if the next block contains indexes from start I plus 1 to end I plus 1, then during the binary search, if your required value is greater than start I and less than end I, it is between this, then you will go to that block, otherwise you will go to below or above block. Okay, so here I want to find how many blocks are there in index. Okay, now one record is of 21 bytes and the block size is 4 KB. Okay, so how many records can I hold in one block? It will be 4 KB divide by 21, and this floor value, right? So this will be how much? We call this as blocking factor also. This will be 4096 divided by 21. It will be 195 point something. So this will be 195. So in one block, I can store 195 record of index file. Okay. So how many blocks will be there in index structure? Number of blocks is total number of records divided by number of records in one block and the ceiling value, right? And this will be 9500 divided by 195. This will give you 48.71, that is 49 approximately. Okay, now what you have to do in order to get access to a particular data, you can run binary search on this 49 blocks only. So it will be log 49 base 2. This will be how much? 5 point something, that is 6. So you require 6 block accesses to reach to the pointer in which data is contained, and 6 plus 1, that is 7 block accesses to get the exact data. Okay, otherwise here you will require this much block accesses. First of all, no, this will not be plus 1, because here you are directly searching on the given data. Here you will require this many block accesses. You can also apply binary search on this. Why? Because this is also shorted, because we are applying primary index, right? So it will be log 9500 base 2, and this will be 7. Okay, this will be how much? 2 की power 10 is 1024, 2 की power 11 is 2048, 2 की power 12 will be 4096, 2 की power 13 will be 8000 something 192, 2 की power 14 will be 16000 something. So this will give you 14 block accesses, and here you will have only 7 block accesses. Okay, so this was your example for primary index. Okay guys, so I think that's all for this session. I hope you had a good revision of the previous year questions, and it will help you in your exam. Best of luck everyone for your exams. Thank you.